Hey guys, so I'm Eito, and I'm going to be talking about ZK microphones, which is sort of a beginning to a solution against deepfakes in this world where the cost of content generation is moving down to zero. So deepfakes already have a potential to pose a state-level threat to society. You can see examples of, for example, Trump getting arrested or pictures of that. The Zelensky deepfake that's telling the Ukrainians to retreat because, I don't know, Zelensky surrendered to Putin. And just a lot of revenge porn deepfakes as well. That's really ruining the lives of many women. So the naive solution that you can come up with for how to protect and verify authenticity and provenance of content is just having cryptographic signatures embedded within the audio. So for example, for a microphone, you might have a secret key that is in the secure enclave of the microphone, and then you would essentially sign the audio, and using public key cryptography, you can verify that a particular audio that was signed with the secret key was indeed recorded on that particular microphone, and verify the hardware authenticity. So you know that a given audio was indeed recorded with a specific microphone. Now, there are a few issues with this. One of the issues is like, okay, well, let's say there was background noise in the audio, then you can't do anything about it. Like, if you try and edit it out, it just destroys the signature. If there was confidential information that was mentioned in the audio, then you can't censor that or bleep that out. And you also can't run compression algorithms to essentially make the audio more storage efficient. And so there's been a rise by a coalition of companies, namely like Microsoft, BBC, Intel, Sony, etc., of a rising standard called C2PA, which is essentially, okay, you do this whole signature thing on a hardware level, right? So you still sign the audio with some kind of secret key, but then, let's say you have an audio recorded and you want to bleep out some stuff. Well, you will use some kind of audio editing software provided by the coalition, and then you will basically say, hey, I edited this audio like this, and send that to the coalition, and the coalition will sign the audio for you to verify that the edit was done correctly, so that you can, compress your audio files, you can bleep out sensitive information, and etc. And then verify the hardware authenticity by verifying both the hardware signature as well as the proof of edit signature, which is provided by the C2PA coalition. And this is generally considered to be, in the original Web 2 world, to be the solution against deepfakes. There are issues with the C2PA standard. Namely, it's just the fact that it's extremely centralized between the coalitions of the Microsofts, the Adobes, and the like. And you end up with the situation where the power is centralized between the coalition. You don't have censorship resistance. If Microsoft wanted to censor something, they can totally do that. And you also don't have this end-to-end encryption. So user privacy is violated by the C2PA coalition. And so that's why we came up with ZK microphone as an initial step towards solving this deepfake problem, as well as the problem of centralization with standards like C2PA. And we actually became the most engaged ETH global project of all time. And yeah, this here is the actual microphone we built. So what we built was essentially a Raspberry Pi hardware microphone where you have the signature on the Raspberry Pi, and then we built also an editing software. So how it worked broadly was, okay, so you still have the Raspberry Pi and the microphone, and you just do the signature using the secret key stored in there. The Raspberry Pi was supposed to sort of substitute for a secure enclave, and then you have some kind of video editing operation. In our demo, we just had it so that you can bleep out, let's say, I think 1 second of the audio, and then you just create a zero-knowledge proof, right, of the bleeping operation, such that it preserves two properties. So number one, you want it to be privacy preserving. So when you bleep out the audio, you want it to be the case that you don't know what was said in the original thing. And signature preserving, so it preserves this original digital signature that was signed on the audio. So you can verify that it was edited correctly and that it came from a legit microphone. And then you get around the C2PA sort of centralization problem by essentially storing the audio and the signature, so the proof of edit, into IPFS, and then just verify on like a layer 2 or a layer 1 or a layer 2, which you assume to be sufficiently decentralized. I think one of the coolest technological innovations we've made while we were developing ZK microphone was essentially by optimizing the proof generation time by operating the proofs in the hash space rather than the actual audio files themselves. So we were using like WAV files because they had nice properties, but the problem is the file sizes got pretty big pretty quickly. So something like 5 seconds of audio would be something like 500 kilobytes, and trying to run ZKPs on that was extremely, extremely slow. So what we did was essentially you have the original WAV file, you would use this particular hash function, the polyhash function, to essentially turn it into a hash, and then you would generate zero-knowledge proofs of the composed transformations that you run on the audio, and then generate the proof as well as the subsequent edited audio. And the reason why this is great is because, well, for one, it shortened the proof time from something like 5 hours to 5 seconds. And the other thing is, because you're operating on the hash space, this sort of, the data size that you operate on here is all constant size, which means it also extends very nicely to other types of larger media files, such as video or photo or any kind of other sensors that you can have. And no matter how big they are, you compress them into the exact same size hash of 256. And so you can run these composed transformations in a way that still is ZKP, I guess, preserved, and generate the proof in exactly the same time. So those were some of our main innovations. And then where we're sort of going with this potentially is to build like open standards, unlike C2PA, which is extremely centralized, to essentially build an open standard that people can use on the internet to make sure provenance of content on the internet. And you can contact these guys here to get in touch to talk about content provenance. And that's it. Thank you very much. Do you want this one?
I think we got it now. Thank you. Thank you very much for the talk. Any questions on that? 1, 2, that's it. First bidders. Let's start with you. Yep.
Hi there. I might have missed this, but when you were talking about operating in the hash space, don't you need to know how your how your audio editing transformations operate in hash space? Like, don't you, in effect, need to be able to commute taking a hash and performing the transformation?
Yeah, exactly. So that's why we used this particular hash function in like the specific like operation that we did, which was just like zeroing out the bits. You would need to be a bit more clever in the way you like engineer the hash space so that you, as you said, you have the commutativity. But you can design different hash functions depending on what kind of operations you would need to do. And then I think you can get around that problem.
Cool.
A couple of unrelated questions. First one was, are you using something like recursion to compose the transformations? And second question was, have you had much engagement yet with trying to build these open standards?
We're not using any recursion. I mean, we wrote all of the circuits just using Noir without any of like the private public state like functionality. We just used as basically a circom like substitute. And then as for the open standard, it's not something that I'm putting personally a lot of time into, but I think it's interesting as a countermeasure to the coalition. And CTPA is still this very like niche thing that's only known between like web enthusiasts. And I think there will be space to where that would make sense, especially due to sort of like intercompany politics between, let's say, the Microsofts and some other competitors and stuff like that. Because this, the CTPA, it's quite subtle, but it's actually like, if C2PA works, it effectively gives a power to like these coalition companies to determine what is true and what is false. And that's sort of a asymmetric power that probably shouldn't be controlled by any singular entity, or in this case, I guess, an oligopoly.
We actually have time for one more. Wonderful.
How, like you mentioned this confidentiality and this peer-to-peer, like how are you achieving that in this mechanism of hashing, then applying editing transformations and getting the proof?
Sorry, what do you mean? Could you...
Like you mentioned this, the problem of confidentiality, that you don't want to reveal the whole audio, but you want to reveal the proof. Like how is this method like achieving that by going into the hash space and then like applying the...
Got it. Yeah, the hash space, where is it? Yeah, the hash space stuff is just a optimization to like make it faster. But like, just imagine we don't do any of this hash stuff. It's just a straightforward like zero knowledge proof of computation, where the zero knowledge element is the like the privacy preservation, where you don't know what you cut out. And then like the succinctness is just like, when you submit the proofs on chain. And then like, yeah, the way to think about the hash function, the hash space thing is basically, we just do it so that you're operating on like on an absolute basis of fewer number of bits, but you also know that like the hashes and the audio match, and there's a one-to-one mapping, assuming that there is no sort of hash collisions between different audio files. Yeah?
Wonderful. Can I quickly ask, does it work? This works then for highly compressed audio too?
Sorry?
Does this work for compressed audio in the end?
So for compressed audio, I think it will be a bit more complicated, but as long as you come up like with the appropriate hash function, you should be able to. Like we spent majority of the time actually working on the appropriate hash function, such that it's like, it preserves the right properties with like the specific edit operations that we were doing, and you just like need to make sure that the commutativity holds when you're doing these like the specific operations. I don't know how audio compression algorithms work, admittedly, but you would make it so that like the commutativity like holds.
That's fascinating. Well, keep us posted. I think ZK Podcast needs to be the first ones to use those mics.
Yeah.
So yeah, thank you very much, Eito.